so today's homework, assuming we get far enough into the lesson that we can, I'm going to post it no matter what. But 8.4, we're going to probably not get done with the lesson since we still have to finish 8.3, but we'll get working through it and see how much we can accomplish. So did anyone have any big questions from yesterday's lesson? Anything that we need to go over before we move forward? You thought it was E? Okay, so I wasn't here for the lesson. Who can re-explain what our process is for solving these two-step equations? Thomas?
So first, like, you have to do, like, if they're two-step equations, it's like say, like, the one at the top of the back. It says 5b minus 3.75 equals 26.25. You add first. You do like you do the opposite of PEMDAS.
So if I asked you what, like, the first step that you guys were doing yesterday was, what would you say that first step was? It's on the front of your notes.
Inverse? No. Undo, addition, or subtraction.
Undo the addition or subtraction. So Thomas, I like that you said we have to add first, but that's specific to the situation on the back. So right here, because there's subtraction happening, we have to add first. But then our next step is to undo multiplication division. Now, here's where today is going to change things. Up here in our learning target, I can solve equations using the distributive property. If there's parentheses, we have to deal with parentheses first before we start solving. So that's not part of solving the equation. Today we're going to get into simplifying the equation first, then solving it. So if we come to here, you guys had this problem. You're ordering concert tickets. Now, in a situation like this, I'm not given the equation. Right, Bunger? I'm not given the equation, so I need to make the equation. So what did you guys hopefully underline, circle, highlight? What did you notate? By the way, I got colored pencils over there if anyone wants to use those for writing out your solutions. Colors can help your brain a lot. What did you guys write out, or what did you underline, highlight? What's important here? Crystal? Yeah, each ticket here is going to cost $39.95. Now, do we know how many tickets? No. So this number of tickets is my unknown amount, but the number of tickets relates to the cost of the tickets. That's why I'm going to highlight those in the same color. And then I know this processing fee, how many times does that happen? Once. I asked the guest teacher yesterday to emphasize this. When you make a purchase online or whatever, a lot of times if there's any fees, they roll it into one fee. So they're not going to say you have this fee and that fee and that fee. They're just going to say you have this much in fees. So that's your total processing fee, and then your total amount that everything cost. So did you write out the verbal part of this equation?
Yes.
What you should have is the cost of the tickets plus the fee equals the total that you spent, right? You have that on your paper? But then the cost of the tickets gets broken down. Yeah, we know the price per ticket. So we could say, I'll say price of 1. And then the price of 1 ticket, what's that going to be multiplied by? The number of tickets. So you can always use hashtag. That actually means number. Plus our fee equals our total. So now, did anybody write down the numerical form when we replace it with numbers? Karina, what do you got?
So 39.95.
39, hold on, go slow, 0.95.
Plus 12.75.
Ooh.
Subtraction.
Not, so that's why I emphasize that this fee only happens once. So the first thing that we need to deal with is everything we know about the ticket cost. So we know the price of 1 ticket, but that actually has to multiply by my number of tickets. So that $39.95 is going to be multiplied by some variable. I'm going to use N for number of tickets. I just don't like using T. Now, Karina, we add
12.7
the 12.75
equals $212.
equals $212.50. So now, switching over to cards, because conveniently, Karina, you were on the top of the stack. Oriana, what would I do first to start my solution process?
Make the multiplication. No, make the addition subtraction.
That's not. I think I agree with what you're trying to do, but you said it in a way that we can't. I can't just take this addition and make it subtraction. So what do you actually? We want to do something on both sides, right?
Oh, you need to subtract 12.75 from both sides.
Yeah, so what we're actually doing is performing a subtraction on both sides. Again, it might be helpful for you. Draw a dotted line from your equals, because that will keep your left side split from your right side. We subtract that. Now, guys, really, if you just reach for a calculator for this subtraction, the 12s cancel out. Take away 75 cents from 50 cents. You have a lack of a quarter. So my right side ends up becoming $199.75. You should not have needed a calculator for that. I should have stopped you, really. My left side now is just the $39.95 times n equal to my $199.75. Isaiah, what do I do now to finish out solving?
Divide both sides by 39.9.
Yep, I divide both sides by my coefficient or my multiplier, whatever you want to call it, the number in front of your n. It's multiplying, so we divide. And we find out that the number of tickets that they bought was 5. And you would want to label that tickets. Questions on what we just did? Any questions on setting it up or solving it? We're good? All right, try the got it on your own. In this situation, you are going to rent a boat. Now, what you know is it costs $60 for the first hour. And this is how a lot of places work. When I used to DJ, this is how I would charge. You charge more for the first hour because you get the boat or you get the services. For me, for DJing, it was because I had to drive there, I had to set up, I had to do everything. The first hour is expensive. Every hour after that is cheaper. So this $60 is only the first hour. This $20 is every hour after that. I will warn you, most people make a mistake on this problem. So I want to see if you guys can set it up and solve it for how many total hours you had the boat. Imagine you're in one of those like white swan paddle boats. Ohio's state song is actually a song about drifting down the river in a canoe. It's called Beautiful Ohio. See some of you sitting and not trying. You want to try to write down an equation. Ask yourself, what is constant? What only happens once? What is going to multiply with a variable? Because if it happens over and over and over and over again, we'd rather just multiply than doing repeated addition. What's my variable? How are they all attached? Then, how do we solve? Now, Abby, can you remind me what I've said? It's not exactly what's right, but it's what I've said is the easiest way for setting up equations. What do we normally try to put first? Sure, tell me what your equation is right now.
I put 60 plus 20x.
I agree with that. So Abby was representing the time that you have the boat, like your expenses. You paid 60 for the first hour, and you're going to pay 20 for every hour after that. I'm actually going to make that H for hours. But I like to write this with the variable term first. So I'm going to flip this around, and I'm actually going to write 20h plus 60 will equal what? 140. Now that you know the equation, you should be able to solve it on your own. But again, I'm telling you, most people goof up this problem. The question very specifically is saying how many hours you kept the boat. Who thinks they know how many hours we kept the boat? I want you guys to shut your eyes because I'm just curious about something.
What?
Who thinks it's 4? Who thinks it's 5? Keep your eyes shut. Who doesn't know how to solve this? Who still would need a little bit more help? Okay. All right. Hands down. Eyes open. Eli, what did you do first here when working towards isolating that variable?
First I subtracted 60.
Yeah. Undo any addition or subtraction. Really, did the guest teacher say talk about we are combining the constants? So both of these values, the 60 and the 140, they're constant values. I know what they are. They're not going to change. So what we're really trying to do is combine like terms, but since they're not on the same side of the equation, that's why we use inverse operations to combine them. Because these destroy each other. These combine to give me just 80. So when I put my like terms together, I now have just 80, and that is equal to 20 times h. So then, Luke, what would you do next? Divide by 20 on both sides. And what do we get? 80 divided by 20? 4. Is that my answer?
No.
Who can explain why? Longer?
Because you have to add the first hour to it.
This first hour already happened. So these 4 hours are my additional hours. So we would need to say plus the first hour will equal a total of 5 hours.
I did it.
You had that boat for 5 hours. Now, like up in Maine when we rented boats, you maybe weren't in the boat for 5 hours, but if you take it back, somebody else might take it. So if you want to keep it for like the whole day, you just keep it. And you just, like maybe go to lunch and then you go back out in the boat. And then maybe, you take a nap and go back out in the boat. So maybe they weren't in the boat for 5 hours, but they kept it for 5 hours. Does this make sense?
Yes, it does.
Any other questions on yesterday's lesson?
Tomorrow, is there a test tomorrow?
No. We're not done with the chapter. I might do a short little mini mastery, like just a little quiz, but it'll probably be another self-check, like a self-grade. Okay, that's okay. So if we have a quiz tomorrow, it'll be another self-check, self-grade. It won't go in math, but it'll just be so that you can see how are you doing. All right. Do I have a volunteer to pass out today's notes? Whoever gets there. Can somebody tell me, is the launch on there? Is the baker problem on there? Yeah, we're going to skip it for now. Well, actually, we're going to write this out. So, I need your attention up here because we're going to run out of time, so I'm going to start even though not everyone has their notes yet. We have our bagel baker again. Now, he has decided he's not making enough money. He is underselling all of his competition, so he thinks he can raise his price. How did we talk about the price of a dozen bagels? Let's say I don't know what each bagel costs. How did we represent, thank you very much, how did we represent the price of a dozen bagels when I don't know the individual bagel cost? We have it on our notes from the past 2 days. On our one notes, we had to add in that 13th bagel. Now there's no 13th bagel. We just have a dozen bagels. Then we're going to deal with the price change. But how do we represent a dozen bagels? hands. Eli? 12b, right? So when we just had a dozen bagels, it was just 12 times b. Now hold on. Notice I did not write that in the box. Because since this bagel baker decided that he is undercharging everyone, he's going to increase his price by 5 cents per bagel. So would I just write this as 12b plus an extra 5 cents? Cassie? Okay, questions?
Why do you keep putting the multiplications into 12 and 15? Can't you just do 12?
Yeah, you don't have to put it, but I put it just to re-emphasize it's multiplying. You can also write it like this, and that shows that it's multiplying. And I'd never heard this, so I was talking with my friend last night, Dave. He teaches 4th grade math. He said that these numbers are hugging each other because these kind of look like hands or arms or something. So because they're hugging, they're multiplied by each other. So I thought that was kind of a goofy way to remember it. But if that helps you, parentheses always indicate multiplication. I don't need the multiplication symbol, but I just like to put it, especially because then it reminds me, hey, if I see multiplication, I need to divide. So it just helps me remember. What if I just write it like this, Bella, what is this going to do?
You're just adding 5 cents to one bagel. Because when you multiply.
Well, we're adding 5 cents to the whole purchase, right?
Yeah,
just to the dozen?
But it needs to be for every bagel.
Ah, so this needs to happen for every bagel. So how should I change what I've written up here to correctly show each bagel is increasing?
Do 12 and 5 tenths times B or you could use
So I could also write this like 12 times B to show the price of a bagel, right? But this plus 0.05, that would only add 5 cents once. If I want to add 5 cents for each bagel price,
It would be times 12.
what I'm doing is changing this, right? I'm adding 5 cents to the B. So what I can do is just put parentheses here. Because now I'm going to add the 5 cents to each bagel's price before I multiply by 12. So your expression that you want down here is 12 parentheses B plus the 5 cents. Because each B, every bagel, sorry birthday boy, can't get quiet. Each bagel price increases by 5 cents. Does that make sense? Why we have to put it in the parentheses? Yeah.
Multiply 5 times 12.
Yes. How? Yeah. So, but that still doesn't really it's just doing the work in a different order. You did the same work because we will eventually, when I then go to solve this, I'll distribute the 12 to the B and I'll distribute the 12 to the 0.05. So Ethan's right. If I want to rewrite this in another way, this turns into 12B plus 60 cents once I distribute. But I need to know the total price before I can solve it. I don't know the total price, so I can't solve yet. If I knew the total price of a dozen, then I'd be able to solve. So moving on to our next problem. So here's our key concept, showing the distributive property using the algebraic method with variables. I need all of you right now on your notes. What do you think I'm going to ask you to do with those distributive expressions?
Circle around the
Draw the arrows. Sorry, I didn't call you Thomas. Somebody already said it. So you want to draw the arrows from the A to the B, from the A to the C. That then is going to become A times B plus A times C. Over here, because there's a minus in between them, this is now A times B minus A times C. Some equations are easier to solve if we distribute first. Some equations are easier to solve if we don't distribute. And all of these can be solved multiple ways. So when I solve it one way, don't think that's the only way. That's just one way. Questions on the whole distributing thing? We've done distributive property before, so I assumed it'd be okay. So we want to look at negative 8x times 0.3 equal to 3.6. So can we solve inside the parentheses? Who said no? Why? Why can't we?
Because you can't first
Okay.
Do you have to distribute first?
Yeah, because there's an x and a 0.3, these two numbers, what do we say about them? They're not like terms. I cannot add them. Remember, you can only add or subtract like terms. Now, you can multiply or divide anything you want. So we can multiply. So the first thing I'm going to do is distribute. That's going to give me the -8 times the x. There's addition between them, so carry down the addition. And then -8, I'm going to put that in parentheses now, times the 0.3. And my right side did not change. Wait.
Why don't you just multiply -8 times 0.3?
I'm going to. I just wrote it out to show like when I distribute, that's what happens. So now -8x, I don't need to write the multiplication between them. I can just write them right up against each other. Now do not touch that calculator. What's 8 times 3?
24.
So just move the decimal back a space. Since it's not 3, it's 0.3. So you had 24 if it was 8 times 3. Move that decimal back, it's just 2.4. But it's negative, so don't forget that. How else could I write -8x plus -2.4? Yeah.
-8x minus 2.4.
Thank you, Layla. I can change the plus a negative to just minus. So instead of writing plus -2.4, I can just make it minus. So now I've got -8x minus 2.4 equals 3.6. So Zach, what would I do first to solve here?
You would add to the 3.6.
Yeah, if you guys get stuck on any of these, I don't know how much the guest teacher emphasized it. This little box right here is a really good reference because once you get to the point where we start solving, you always undo addition or subtraction, then undo multiplication or division. So Zach is totally right. First thing we do, undo the subtraction. So we do the opposite operation. We add 2.4. Still don't touch that calculator. These values work nice together. 6 and 4 make a whole. So that would carry up here. 1, 3, and 2. This gives me 6. So I get -8x equals 6. I'm going to bring that over here just so I have a little bit more space. Bella, what would I do now?
You would divide
By?
-8.
Yeah, we got to divide by the negative, which pay attention. Since I have one positive and one negative, my value for x isn't going to end up positive or negative. Negative, because I only have one negative. Remember, it takes a pair of negatives to make it positive. I only have one negative. So I can really just simplify this. Luke?
So then -0.75.
You're right, but I'm going to do the fraction and then do the decimal. So I could either rewrite it as -3/4 or -0.75. Then to check it, if you ever want to check your answer, grab your value, plug it in to where the x was, and do the math. Because now that I know what x is, if I plug it in here, I can add them together because they would be like terms. Does that make sense? To check it, I just plug it in and do the math because it should equal. Try the got it on your own. You can do it without distributing, but I would like you to do it with distributing because they share common factors. Think about 3/4. Well, that means every time you have 4, if you multiply by 3/4, you end up with 3 because you get 3 out of 4. So try the got it on your own. Draw the arrows to distribute. Do the distribution. Simplify it. Then you can start solving. If you're having issues, please stick up your hand so I can help you. Thank you. I actually haven't not eaten breakfast, but it's okay.
Can you fail the test?
I passed yesterday. Took that my meeting.
You passed what yesterday?
The test. Eminal said that he was testing me one day and didn't remind me about taking my medicine.
Yeah, I heard that in the video.
Yeah.
It was funny.
Wait, can you hear us talking?
Can you hear me?
Not when you talk super quiet.
What?
But like,
Did you hear me? What, can you hear us now? Can you hear me?
hey, so to take 2 seconds, this little thing, I mean, it's picking me up and I'm not talking very loud. Now it's not gonna be loud, but the only way it's not picking anything up is if that's all the way down, which really doesn't happen because there's always some kind of noise happening.
The background noise from social studies.
Yep. So it's always picking up something.
That's actually
Bayla, are you able to talk me through my first step here, what you did? Yeah. So 3/4 times the 8b and 3/4 times the 4. Now here's where you have choices, and there's no right or wrong answer. It's what you decide to do. You can either do 3/4 times 8b minus, and I've used the minus, so I cannot use it again. So then it's 3/4 times 4. Or if you make this a plus, the negative would have to go with the 4. I think it's easier now to just bring it down as a minus and make the 4 positive. Because think about this being minus a positive 4. So then I do the math. What's 3/4 of 8? 6, because if you have 3 out of every 4, I have 6 out of 8. What's 3/4 of 4? 3, because I have 3 out of every 4, equal to -2. Now, Ethan, we're finally ready to start our solving. All of this is not solving. This is just simplifying. All I'm doing is doing the distributive property and then doing the math. None of that was solving. It was simplifying. So, Ethan, what do I do first to start solving? Yeah, I forgot to put my equals here, but yeah, now wait, what'd you just say we would do? Now, what operation is happening? Yeah, we see subtraction, so we need to add 3. So 6b now equals 1. And if 6b equals 1, then Cassidy, how do I find out what just b equals? Yep, I see that this is multiplication, so I have to divide. And you can leave it in fraction form. So you can just put 1/6 as your answer, or if you put it in a decimal form, what's cool about the fraction 1/6?
Oh, it's like it's repeating.
It is, yeah, it's 0.16, but then the 6 goes on forever. So you'd have to have the repeating bar over it.
Oh, I thought it was that one that goes like 14, 28, 56.
Now, actually, I will try. If somebody can remind me later, a friend of mine who is, I'm not certain if he's an engineer. I think he's an engineer. Put up a post about the dangers of Chipotle, but there was math involved in it, so it was kind of funny. So if somebody reminds me later, I'll screen capture that post and I'll show it to you guys tomorrow.
I don't like Chipotle anymore.
So he was talking about how many people have gotten sick. You know, Chipotle is having like this health safety scare. People are getting sick from their food. So he said, like, well, if 1,000 people have gotten sick and Chipotle serves 800,000 people a day.
Wait, they do?
Yeah, what's the or something, 80,000, something like that. He said, what's the probability of getting sick? And he figured out the percent chance of getting sick. It was less than 1%. It was actually less than 0.5%. So he said, you know what? I don't care. I'm going to eat Chipotle. Because they're not closed. Like Jenny's closed down. Chipotle's still open, but they're just having like a safety scare. I don't think they are closed right now.
No,
but
I don't like it anymore. I used to kind of like it, but now I don't.
there's wisteria. Yeah. Try.
Dude, everybody, who likes piata here?
I like food.
I just like putting it.
Myra requirement is that it's food. So, when we're faced with these different types of problems, you want to take a second, back yourself up, and ask what needs done to this problem. So when we look at these problems, and you obviously can't drag tiles on your paper, so I gave you lists on your paper, you want to write down the equations below those lists. So whether it needs one operation, two operations, or needs more than two operations, which would be something that needs distributed, something where we have to do a lot of work. So Crystal, when you see this equation right here, 72 equals m plus 12, how many operations do you think we would need to perform to solve it? What would you do first there? Subtract 12, right? And then once you subtract, is there any multiplication or division that needs done? No. The m is already 1m. So once you subtract the 12, you're done. So how many operations was that? 1. So this actually would only need one operation because the m has nothing else done to it aside from addition. Brennan, what about a divided by 2 equals 10? What would you do there? Well, what's happening to the a?
There's
One operation? So back up. What's happening to the a? It's being...
multiplied.
What? It's being divided. I think you're thinking we would multiply. But the way to solve this, you would just do times 2, and then you'd be done.
Yeah.
So a there would equal 20. Layla, what about this one? It would actually need more. So because we'd have to distribute, and then we'd have to add, and then we'd have to divide, because I see the parentheses and I see the distribution, it will take more than 2 operations. Some of you guys are choosing not to write these down. My suggestion is that you do, so on your homework you know how much work to expect. Divine. What about this one? How many operations? Think in your head, what would you do to solve this? So what would you do? Go through the process. First you would... Is there anything to distribute? Are there any parentheses?
No.
No. So first we would... Yeah, we'd add first because we want to undo the subtraction. Then, once you undid that, what's being done to the a still? Yeah, then we would divide 2 steps. It would just need 2 operations.
Well, that does not look like it would be. Yeah.
All you would have to do is add, then divide.
I think because there's a lot of numbers it looks like.
Thomas,
Oh, yeah.
what about this one?
That one. That needs more than 2.
How did you know, like, immediately that it needed more than 2?
I saw parentheses.
Yeah, the parentheses, the necessary distribution. Thomas knew I got to do that. Then I can start solving. Either way, it's more than 2 operations. And Franny, bring us home. How many operations on this one? Needs 2. What would they be? Yep. We'd subtract the 13.9, then we would divide by the 6. Any questions on these? How we determined that?
Wait, did I miss?
Check it. Correct.
Wait, I'm not.
Did she show any of those yesterday? I told her, like, if she wants to show them, they just show, like, goofy faces. Like, I was showing her the lesson and she laughed at it. She was like, that's weird.
You didn't show us.
What did you guys think of the guest teacher?
She's really nice.
She was?
nice.
So, I'll tell you why you think she's so nice. Anyone guess what her certification is?
Yes.
Math.
Math.
Nice.
Science.
Elementary school.
Niceness.
That's why she's so nice. She's an elementary teacher.
Niceness?
Elementary teachers are, like, nice. You know, nice. They have little kids. They can't be mean.
Well,
Try.
we don't have
Now. Yeah, it's on the back. Actually, so that we have time. Did that ding? Okay. So that we have time to get to a little bit more. I was gonna have us solve these, but we'll just answer actually what question it asked, which require 2 or more operations. So I really want to under these. I just want to say how many operations they would take and what they would be. So in the first one over here, Eminal, what would be the operation that we would do to solve this?
Division.
Here's the trick again.
That's multiplication.
By what, though? Because instead of dividing the fraction, what do we do, Eminal? By what?
20.
By the reciprocal. So everybody below number 1, you need to write multiply by reciprocal because you all keep forgetting that. Multiply by reciprocal. Which in this situation would be 5/4. The second one, Karina. What would you have to do? Like, what would be the order of the things that you do? What do you see has to happen first?
We've got to draw the arrows.
Yeah, so we would have to distribute. Then we start solving. Okay, Divine, notice how like everyone's writing except for you. Then we would, so that's step 1. Step 2, we would have to add to undo the subtraction. Actually, this is tricky. Here it would actually be subtract. This is going to be the prize problem for today. Who knows why I would actually subtract? Who can explain the process? Brennan, your hand shot up. Do you actually know the answer or just because I said prize? Isaiah?
Because the -5 is, because it's -5 and the 1 is also negative.
When we distribute, the negative times the negative would make it turn into a plus. So then we would actually subtract. And the last thing we would do would be to divide. So that one takes 3 steps. My third one here. Katie, can you tell me what I would do first? Yes, ma'am. I would add the 19 to both sides. And the next thing I would do, what would be the... You would divide... Actually, because we see the fraction here, multiplied by what? The reciprocal. So again, write down, and you can abbreviate it now if you want. You can put mult, like with a period. Whenever you abbreviate, make sure you have that period. I'm just going to say mult by recip. Recip should be able to, tell your brain, oh, reciprocal. If you just put REC, REC is kind of too short of an abbreviation. Like recreation or, yeah, it could mean a lot of things. Could mean recess. All right, we have 4 minutes left.
Can you show us the Chipotle thing?
No, that is going to happen tomorrow. Because I have to look it up and screen capture it and everything else. It'll take too long. So, a family of 6. We want to work through here. Start by underlining, highlighting, or circling the important information. Then we want to set up the verbal equation. And then we want to work it. Simplify and then solve. And I don't just say solve because the first steps we have to do is simplification. A family of 6. They do this sometimes to throw you off when they write numbers as words. Pay attention that it's still a number. It's just written as a word. Buys airline tickets. Travel insurance costs $19 per ticket. That per ticket's going to be really important. That's happening on every ticket. So instead of the fee that only happens one time, that happens every ticket. The family gets charged a total of $1,116. How much does one ticket cost? So we know what about this situation. Bella?
Each ticket is $19.
That's not the ticket price. That's the insurance. How many tickets did we get? 6. So we have 6, and that's going to multiply by the ticket price. But every ticket also has a fee. And then that's going to equal our total. So then, I got time. I don't know why she's releasing so early. I got time. We need to replace what we know. So, I know the price of a ticket? No. Do I know the fee? Yes. So, since I don't know the price of a ticket, what do you want to use to represent it?
C.
I.
K.
I'm going to use A for airline ticket. C would work too for cost. We use C a lot of times for cost. The fee was $19 for each ticket, and the total is $1,116. Put a comma in there so you can see place value. We're going to finish this. Guys, quick. Can you respect the fact that we're having class? So the first thing we do is distribute. I'm going to keep you here till we're done. And if I see people stop writing, I'm just going to wait. So first thing we draw is our arrows. We then get 6a equals, anyone do 6 times 19 yet? Think about 6 times 20. That would be 120. Take 6 away from it. 114. Sorry, I wrote an equals there, but it should have been a plus. Equals 1,116. We got to take away all those fees. So we subtract by 114 on both sides. I'm running out of space, so I'm going to have to move over here. That leaves me with 6a equals $1,002. Last thing we do, class? Divide by? Yep. Divide by 6 on each side, which tells me that each airline ticket, and guys, this is cheap for a flight. What'd you say it was, 167? That is cheap for an airline ticket.
How much is the airline ticket?
Anywhere from a couple $100 to $1,000. Depends where you're going. All right, we will finish this lesson tomorrow and have a quiz. Be ready for a short mini mastery.
So is that going to be us too?
Yeah, essentially.
Surprisingly.
Why are so many of you going to be gone?